Questions 1a and b are achieve level questions. Question 1a, differentiating 2x minus 3e to the 2x minus 1. When we differentiate the expression e, it stays the same. Just make sure you also differentiate the power, the 2x minus 1. And that's where the 6's come from. 3 times 2 from differentiating 2x minus 1. Now in part b, our first step is to change the square root of x to x to the half. And then we just do the normal differentiation. Multiply by the power, subtract 1 off the power. We can leave it as 2 square root 2. We don't need to get into the decimals for that. Question C asks for the sum of the number and its reciprocal. And that's where the x plus 1 over x has come from. Now we need to differentiate that because we want to get it as small as possible. Any minimum or maximum, we differentiate and put our differential equal to 0. And so from differentiating x plus x to the negative 1, we get the 1 minus x to the negative 2. Because I need to solve this, I'm going to rewrite it back as 1 minus 1 over x squared. And when I go through and solve this, I end up with x squared equals 1, x equals plus or minus 1. But back up in the original question, we're told x is a positive number, so I just accept the x equals positive 1 and disregard x equals negative 1. On the original function, I've labelled the top there point A. That's because two things happen here. It's where two different types of graph have met, the straight line graph and the parabola graph, and it's where the gradient of the parabola is 0. So if I drop a vertical line down, that's going to be a significant point in my derivative graph. At the part where x equals a, I've got a gradient of 0. To the left of that, the straight line has a constant gradient of perhaps negative 1. Now, I don't know exactly what the gradient is of that sloping line, but I've put its gradient going across to the left with a hollow circle where it meets point A. And for the parabola, if we look at a parabola as being negative x squared, it differentiates to give negative 2x. And so I'm looking to draw the line y equals negative 2x, and it's going to go through the point 1, 0, because at point A, the gradient's 0. So our gradient function for the original curve given is a horizontal line giving the constant gradient for the part on the left-hand side of the red line, and a diagonal line for giving the gradient for the parabola. Because the excellence questions have quite a few little bits to them and take quite a bit of explaining, I'm just going to leave it like that, and if you have any questions, just ask at any time during class time. The theory for this question is that little box on the right hand side. If y equals log x, then dy dx equals 1 over x. For our function, we've got function x equals log brackets 3 plus 4x squared. I differentiate and I get 1 over 3 plus 4x squared. And the 8x comes from differentiating the 3 plus 4x squared. To find the gradient when x equals 1, quick substitution, x equals 1, gradient 8 over 7. To find the rate ds dB, I need an equation that has s and b into it. So I'm looking at this triangle here, and I'm going to use tan beta, opposite over adjacent, tan beta equals 20 over s. Now, in order to get the ds d beta we require, I have to turn that equation around, because ds d beta comes from the equation s equals. And so a little bit of cross multiplying, and we now have an equation s equals 20 over tan beta. And to differentiate that, I'm going to bring the tan beta up, and so it's come to a power of negative 1. Just like what I've done over in that little blue box there, 20 over x, 20x to the negative 1. We're now ready to do our differentiation. On our formula sheet, it tells us if we differentiate tangent, we get secant squared. And so 20 tan beta to the negative 1. The negative 1 comes out the front, makes it negative 20. Tan beta to the negative 2. And now we differentiate tan beta, and it's secant squared. Questions like this one, sometimes it's too difficult to rearrange and get y equals. So we use a method called implicit differentiation. And the first step would just be to cross multiply so the equation just fits on one line. And then we start differentiating, and differentiating 5xy cubed, we do that as a product rule, and then a plus y squared, giving 16y dy dx. The next step down, the last step for the answer, is to rearrange to get dy dx as the subject. This one's likely to require quite a bit more explanation, and so just ask in class time if you don't follow what I've done. There's a bit of preliminary working for this question. We need to find the value of t when x equals 8. X equals 2t squared, solving gives x equals 2. I need the two derivatives, dy dt and dt dx. X equals 2t squared, differentiate, dx dt is 4t. Do the reciprocal, and I get dt dx equals 1 over 4t. For y equals t cubed, dy dt is 3t squared. Now we can use those two bits here to get the dy dx equals 3t squared times 1 over 4t. Dy dx equals 3/4 t. For the second derivative, the shaded part there is a bit like theory. All we need to do is differentiate the first derivative. So differentiating 3/4 t gives 3/4, and then multiply by dt dx. So always for the second derivative, differentiate the first, multiply by dt dx. And that simplifies to 3 over 16t. We asked for the value of that second derivative at 8, and this is where we use that t equals 2 I found right at the start. So 3 over 16 times 2, the second derivative, dy squared over dx squared, is 3 over 32. For this excellence question, the key to it really was to extend the cup down to a point, and that forms two similar triangles, and that's where we're going to get our ratios for R and H from. And following through our working, we end up with the HDT is 20 over 9 pi. Again, any questions, ask in class. In question 3a, we're going to use de Moivre's theorem. And so square root 2 45, cis 45, becomes square root 2 cubed, cis 45 times 3. Okay. Another way of writing square root 2 cubed would be just 2 times square root 2. To change that into the rectangular form, we use our calculator, and I've just entered it as rectangular 2, square root 2, comma 135, making sure my calculator's on degrees first. In part B, to find the conjugate, or to use the conjugate to simplify this question, put some brackets in. And if you put your brackets in, then you can expand all the terms, dealing with surds such as square root 2 times square root 2 equals 2. And hopefully it'll just all fall out and get 11 square root 2 minus 12 over 14. We need to look at that question we've got, the mx squared plus 4mx plus 4p equals 0, as a quadratic. So in the little grey box there, I've got ax squared plus bx plus c. The a for the question is the letter m. The b part of it is 4m, and the c is the 4p. So substituting into the quadratic formula and simplifying down, we hopefully end up with negative 2 plus or minus 1 over m square root m minus 4p. Question D uses that little bit of log theory, the log of x to the power of n. The n can be written out the front to become n log x. So when I'm solving equations, I can do same operation on each side, such as adding or subtracting, multiplying, dividing. I can also write the word log on each side. And that allows me to apply the log property I've got there. When I bring the power out the front, the x minus p, it goes into a bracket. Similarly, x plus 1 becomes brackets x plus 1 log 4. Now I need to expand that out. Now, from this stage, the question says, find the expression for x in terms of p. So I've got to rearrange this whole expression so it finishes up saying x equals. And whatever x equals, it can be a number or it can be expression, but it's got to start off x equals, and in this case it'll have a p somewhere on that right hand side. Expand the brackets, x log p, so x log 3 minus p log 3 equals x log 4 plus log 4. I want x equals, so the two terms with x in it I'll collect on the left side, and the log 4 plus log p log 3 I'll collect on the right hand side. And now with those two on the left, x is a common factor which I can factorise out. And so I can take x out as a common factor and then divide by that common factor, the bracket, and I get my expression that I need. It's just like dealing with 2x equals 8, divide by 2. So x times bracket equals, divide by the bracket. Now, we want the real part of this complex expression, z plus 2i over z minus 2. The first step is to replace the z with x plus iy, and then start collecting terms and simplifying, expanding, all that sort of stuff, normal algebra stuff. We're trying to find the real part of our final term, and that's where the real part is, well, if you come back to the original z equals x plus iy, the real part's the x, the part without the I in it. So for this expression down here, again, the real part are the parts without the I in it. And so we're just going to pick out those terms, they equal 0.